Okay, so what we're going to do first and foremost, we're going to just write a couple of different parts in this. You have your R going up, your reaction force. You have your mg going down. At the moment, the system's on the verge of going to the left, which means that the frictional force is going to the right. We'll just call it Fry. Okay, friction. To hell, we'll write the full thing. Right, friction. Okay, now what it says is it's going to be 1.7 plus x. So the force on the particle when is the distance 1.7 plus x. So 1.7 plus x, it has a natural length of roughly 1. The equilibrium point probably will be 1.7. We can prove that in the next part, where we'll prove that if x doesn't exist, it has no the forces will be it has no acceleration, which means that the forces are in equilibrium, and this is your distance x. Okay, starting off, R equals mg. M is 1 kilogram, so it means it's just 9.8. Okay, 1g, which is 9.8. Next part is force to the right is the friction force. So force on the right equals mu r. Mu equals a half of 9.8, which in turn will get us 4.9. So that's your force right. Your force left is going to be the k multiplied by L, take away L0, which is the natural length, your current length minus your natural length. K is, do we know what K is? 7. Okay, oh there it is there, 7 newtons per meter. So 7 minus 1.7 plus x minus 1. That's going to be 0.7, so it's going to be 4.9 plus 7x. Now you've done it properly. FL usually take FR minus FL will usually cancel. Now, which one should be the bigger force in this point in time, guys? The right or the left? The left should be, because you've extended it. Probably it has an extension, which usually means there's going to be a elastic force pulling it back. So net force will equal. Try and take now the bigger one, the smaller one minus the bigger one, which is FR minus FL. The reason why I want FL on the right is I want it to be negative. If it's negative, then it's going to be it's going to prove that it does simple harmonic motion. So it's going to be MA, mass by acceleration, which is going to be 1 multiplied by A. FR is 4.9, and then it's going to be minus 4.9 plus 7x, close that brackets. The 4.9s will cancel. We're going to get A equals minus 7x. The acceleration is in the opposite direction to the extension or displacement x, okay? And because it's opposite in sign, this means it undergoes simple harmonic motion. You also got to remember that we also got to get our periodic time here as well, okay? So we've just after doing part 2. Show that until the string goes slack, it will be formed simple harmonic motion, and the periodic time. We have to find the periodic time. The first question was actually just drawing in your forces. So the first answer to the first part is drawing in your forces. The answer to the second part is what we're just wrapping up here. It's omega squared x. Omega squared has to be equal to 7. Therefore, omega equals root 7. All what we got to do next is do our periodic time. T equals 2 pi over w, or omega. T therefore is 2 pi over root 7. So that's our periodic time. We just have to prove from that. Now, find correct at 2 decimal places the time when the particle will, time in which the particle takes to reach a point 2 meters from P. Okay, 2 meters from P. 1.7 plus x is your distance from P. So what this means is, we defined this whole system that we got a second ago, where A equals minus 7x, omega equals root 7. This whole thing is defined as your distance from P. Distance from P ends up to be equal to 1.7 plus x. He's just after telling us that this entire thing equals 2. Therefore x must be 0.3. Okay? So it wants a displacement of 0.3. Okay. Now we start from the extreme point, don't we? So as I said earlier, equilibrium is here, but you're starting here. So you're actually in the extreme position. Okay. Now the formula for extreme position is x equals a cos omega t, and what we're going to get is x we know is 0.3. Okay, so sorry, 1 second. Okay, the center of oscillation is where x equals 0. It's 1.7 meters from P. It was released when x equals 2. Put a pause on that for a second. You're next looking for the amplitude. You know x is 0.3, which is set in stone because you know it's 2 meters away at the end of the question, which is 0.3 of an extension. However, at the start of the question, it's released at 3.7 meters from P. Now the natural length is going to be, the equilibrium point is 1.7. Now to prove that the equilibrium point is 1.7, you found out that A is minus 7x. If x equals 0, there is no acceleration, which means there is no net force. This is proven that the equilibrium point is in fact 1.7, because the system was set up for 1.7 plus x. So if x is 0, this means there's no acceleration, which means there's no force, which means this is the location of your equilibrium point. Okay, so now that you know that that's your now you know that 1.7 meters is your equilibrium point from P. 1.7 meters from P is your equilibrium point. It tells you in the question that it's released 3.7 meters away. This is an amplitude of 2 meters from the equilibrium point. So now your formula for x is going to be x equals 2 cos root 7t. Now you know that x is 0.3, so you can just put in 0.3 there. And now you just got to go about finding your time, alright? So what you can do, just all of this into your calculator in one go. So your gigantic calculator. So what we can say is it's going to be 0.3 divided by the 2 starting off. Okay, which is 3 over 20. Make sure it's in radians. Now we're going to cos inverse that. So shift cos inverse your answer. Okay, and that's equal to 1.42. 1.42 equals root 7t. Now divide your answer by root 7 and you can figure out what your time is. And our time will be 0.5367, which is 0.54 seconds. The time taken is 0.54 seconds. Okay, and that's the end of that word. Okay guys, this question here. An elastic string has a natural length of 1 meter and an elastic constant of 8 newtons per meter. One end of the string is tied to a point P on a smooth horizontal floor, the other to a particle of mass a half a kilogram. The particle is dragged across the floor. The particle is dragged across the floor to a point which is 1.5 meters from P and released from rest. Show that the particle will perform simple harmonic motion as long as the string is taut. Okay, so what we have here is we're going to have P, which is here. We're going to have our distance from the wall to the equilibrium point. We'll call it here. So this is our point here. So length of 1 meter and elastic constant 8 newtons per meter. One end of the string is tied at point P on a small horizontal floor, the other to a small mass of a half a kilogram. The particle is dragged across the floor to a point which is 1.5 meters from P and released from rest. Show that the particle will perform simple harmonic motion as long as the string is taut. Okay. Now I'm trying to think where would be the equilibrium point on this one, alright? Unlike the last question, there's no friction, right? Yeah? Because there's no friction in the last question, alright, we had the natural length. Today, in this question, we have a natural length of 1 meter. Okay? In the question we did previously, question 9, the equilibrium point wasn't at 1 meter. Okay? The reason why the equilibrium point wasn't at 1 meter was because there was friction. You could actually pull the particle a bit more, and the friction would hold it in place further away. In this question, because the table is completely smooth, the equilibrium point lies at the natural length. Because at the natural length, there is no tension, there is no force pulling it back. So that's why the equilibrium point in this question lies at the natural length away. Okay? So this is the equilibrium point here, which is located 1 meter away. Then what can happen next is you can have your extension x, which drags it to a point where there's now a net force to the left. Okay? So starting off, we're going to go for F equals, this is going to be force to the left equals K L minus L0. Okay? So we're going to set it up for a system with any extension first. So FL is going to equal K, and what's our K value? 8. Okay, so our K value is 8. Our current length is going to be 1 and x, 1 plus x. And our original length is still minus 1. So FL will equal 8x. Okay? Now, is there any forces to the right in this question? No, because there's no friction. Smooth horizontal floor. This means there's no forces to the right. So, therefore, our net force equals minus FL. Why is it minus FL? FL is going in opposite direction to the displacement. Displacement is positive when it goes to the right. Our acceleration is going to the left. Okay. Net force equals MA. The mass of the particle is 0.5 kilogram. The acceleration is A. And it equals minus 8x. Bring up the half. A is equal to minus 16x. This is simple harmonic motion because the acceleration is in opposite direction to the displacement. A is equal to minus omega squared x. Therefore, omega squared equals 16. Omega therefore equals 4. Okay. Show the particle perform simple harmonic motion as long as the string remains taut. Done. Find the maximum speed. What's the formula for maximum speed?
V equals WA.
Phi equals omega A. Therefore, phi will equal 4A. Okay, what is the amplitude though? We need to figure out what the amplitude is. So guys, what's the amplitude of the motion? 0.5. Because your full extension is it's released 0.5 away from equilibrium. Amplitude is always defined as how far did you release the particle from equilibrium. So you've released it at 0.5, okay? So it's going to be 4 times 0.5. This means that phi will equal 2 ms to the minus 1. Maximum speed is done. Find the time taken for the particle to travel 0.2 meters. Okay, you just wanted to travel 0.2 meters. So your starting off position is here. I'll do it in purple. You start off here, and all you want to do is travel 0.2 meters to the left. What does that mean your displacement from equilibrium is? 0.3. So therefore x is 0.3. X is not the distance you traveled, but your displacement from the equilibrium point. Okay? So now we know that x equals 0.3. We know that A is 0.5, and we know that W equals 4. You start off at the extreme point, which is A cos WT. 0.3 therefore will equal 0.5 cos 4t. Okay, go to your calculator. You're going to cos inverse 0.3 over 0.5. So shift cos inverse shift. Okay, shift cos inverse, what's it, 0.3 over 0.5? 0.3 divided by 0.5 equals 0.927. Divide that answer by 4 and the time taken should be 0.23 seconds, which it is. So the time taken is 0.23 seconds. Okay guys, I think we're good to move on to the next exercise now. Okay, so that wasn't too bad. So